Welcome to Supply Chain Management. We are continuing with demand forecasting here and specifically adaptive forecasting. In this lecture, we are going to go over what we call as Holts model. But this is essentially the exponential smoothing which you paid attention to in the last lecture. But now we are going to look at level and trend when it comes to doing that forecast. So let's go dive in right ahead. And this is a trend corrected exponential smoothing or Holts model. And it's appropriate when demand is assumed to have level and trend. There is some trend, but there's no seasonality. So the systematic component is level plus trend. And so you need to run a regression equation. So remember the static model, we ran a regression equation for the deseasonalized demand, and this is essentially the deseasonalized demand. So if this is your demand, your trend is essentially the slope and your level is the intercept. So for time period T, the forecast for future periods is going to be the forecast for the next time period is the previous period's level plus the previous period's trend. If you have data which is beyond the data points, the actual demand data that you have, let's say your demand data stops at 10 and you're looking at forecasting for time period 12, you have to multiply trend with so many time periods away from demand. And I'll show this to you when we do it in Excel. So the revised estimates for period T, so remember you're recalculating. This is an adaptive model, and so you have to recalculate your level and trend. So your level is alpha plus your new demand data plus 1 minus alpha plus the old values. So the old forecast and some percentage of the new value. Similarly for trend now we are using beta, and this equation here, LT plus 1 minus LT, is the level minus the previous time period's level. The difference in the level is the new trend, and then a certain percentage of the old trend. So alpha is the new data, percentage of new data, which is used to update level, and beta is the percentage of new data, which is used to update trend. So let's take an example here. There's a 6 months demand data given to you. Alpha is set to 10%, beta is set to 20. And we are going to use regression analysis. Now, if you're going to do a paper and pen exam, this will be given to you. So your L0, your level, or your intercept is 7,367. Your trend is 673. And so your forecast for the first period, you can calculate using that formula. The error for the first time period, you take your forecast minus your demand. And then you can calculate the rest of the new level, right? The new trend. And with that, you can calculate your new forecast. So, and then continue on, you keep doing that all the way up to the last forecast. So let's, of course, we are not going to look at this manually. We're going to focus on calculating, doing this on Excel. So in Excel, let's take the data. You have the demand data. We're going to start off with alpha and beta of 10%. And then we're going to optimize your alpha and beta to get a minimum mean absolute deviation. So we have to create your trend corrected forecast. Then you got to optimize alpha and beta. Of course, you're going to calculate the error terms, root mean squared error, MAD, MAPE, tracking signal, confidence interval, and then show the plot. So let's go ahead and start Excel right now. So here we have our data. And of course, the first step in every forecasting problem is to go ahead and create your scatter plot. Now, there is an easy way to do get your intercept and slope, and essentially that is to add a trend line. And if you put a trend line and say display equation on the chart, here we have the equation which will give you the intercept and the slope. So you can actually, instead of running the regression equation, you can actually get this using that. Okay, so I'm going to remove the trend line. But if you want to do it properly, then you go to data, data analysis, regression, and here we go, we select this for the Y, this for the X, click OK, and you get the intercept and slope here. All right. So now that we've got the intercept and slope, let's go ahead and put alpha and beta as 10%. And your level and trend would actually be the values which come directly from the intercept and slope. That's the initial level and trend. And therefore your forecast here is the previous time period's level plus trend. Remember this, the most common mistake students make is they put forecast is equal to the same time period's level and trend. It is the previous time period's level and trend. Now, you've got to recalculate level, which will be alpha multiplied by your demand, right? Alpha multiplied by demand plus 1 minus alpha times level plus trend. So here we go. We have that. Don't forget to put the dollar sign for your alpha, because when you copy it down, it's going to cause problems. Similarly, for trend, it would be your new level minus beta multiplied by your new level minus your old level, and then 1 minus beta times your old trend. So here we've got that going. And now all you have to do is catch all three and copy them down here. Paste and paste your formulas here. Okay? So once you paste the formulas, you have your forecast. So now for time period 13, there is no data. So we are going to copy this down. That's still fine. But for time period 14, you are going to have to multiply. This is trend is essentially 2 time periods away. So you've got to get 2 here. So you're going to have to multiply the trend by 2. So 14 minus 12 would give you 2. Similarly, we then finish up time period 15 and 16. So let's go ahead and show this. You'll notice that until this point, we didn't do anything except did previous level plus previous trend. Here we have taken previous level, we put a dollar sign to it. Then we've taken the current time period and subtracted to the last time period, which has data, which is 12. But we have put dollar signs, so this doesn't change. And then we have put dollar signs on trend, so that trend doesn't change. And as we copy down, C15, A15, and D15 will not change. But A16 would become A17, A18, A19, and that would multiply. 16 minus 12 would be 4 multiplied by the trend. That would give you the trend. Okay? Now, of course, all of you have to calculate your level, your errors, your mean squared error, your absolute error, your bias. All of that has to be calculated. And so you can see your mean squared error, MAD, MAPE, all of them is calculated. You can calculate your confidence intervals, and your confidence intervals can go all the way right up to this point, right? So this stuff is the same no matter what. So it doesn't matter what your forecast is. Once you get your forecast, all this can be just copied and pasted directly in. Now we've got to do the optimization part. For you to optimize, you've got to, of course, the first step is to copy this, create a copy, make sure these values are all numbers, there are no formulas, right? And then you're going to take Analytics Solver and you are going to minimize your MAD. This is what you're going to minimize. And the variables you're going to adjust are, these are the variables you're going to use to optimize them. And your constraints are alpha and beta. Alpha and beta are less than 1, right? And then alpha and beta are greater than or equal to 0. You have to put these two constraints in. And then you can run it. And here you go. So essentially here, alpha and beta is 0, which means this is a static. You'll notice your trend doesn't change. Trend is pretty static, right? It's 253.82 no matter what you do. Here's your intercept, here's your slope, which is your trend, and then it remains constant. All right, and you get an MAD of 240. All right, and this is your optimized value. And with this, we've finished trend corrected exponential smoothing.